Today we are going to talk about greatest common factor. Here are some helpful definitions. You should write this on your notes page in your math journal. A factor is a number multiplied by another number to find a product. For example, here are some factors of 6. 1 and 6 and 2 and 3. Because 1 and 6 multiply together to get 6 and 2 and 3 multiply together to get 6. There are 4 factors of the number 6. Remember our classroom discussion, also we talked about prime and composite numbers. Just to go a little bit on a side note here, a prime number has only 2 factors, and those are only one in itself. So for example, like the number 3, the only 2 numbers that multiply together to get 3 are 1 and 3. Same thing with 5, 7, and even 2-digit numbers like 31. Numbers like 6, where there are more than 2 factors, are called composite numbers. The greatest common factor, also referred to as the GCF, which you'll probably see me refer to most often, so please remember both of these, is the greatest factor that 2 or more numbers share. You'll see those in the examples coming up. Here's our first example. In these, all we are doing is listing the factors for each of these numbers. This is another place in which your divisibility rules can help you, but listing the factors and knowing the factors and the greatest common factor of each number is going to help you when you're simplifying fractions. It's going to make it so you don't have to do too many steps when simplifying a larger number. So first, let's start by finding the factors of 12. Here's the way that I do it. I always start with 1 and the number, and I kind of spread them out here so that when I list my factors, they're in order. I then go through sort of my divisibility rules, but also kind of think about my multiplication facts. I now think about the number 2. Well, I know that 2 times 6 is going to give me 12. Now I'm going to think again. I'm going to go to number 3. Well, I also know that 3 works because 3 times 4 is going to be 12. Now I might move on to 4. We already know 4 is a factor because 3 times 4 is 12. Then I might think of the number 5. Well, I know that 12 is not a multiple of 5, and 12 is not divisible by 5, so 5 is not a factor of 12. Now I've kind of gone back over. Now I start with 6. Once you start repeating the factors again, then you know you can stop. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Now let's take a look at 32. I'm always going to start with 1 and 32, and I spread them out to give me room to add other factors. I'm now going to take a look at 2. Well, I know 32 is divisible by 2 because it ends in an even number, so it's going to be 2, and I know that it's 16. If I didn't, I could do some work on the side. Next, we'll look at 3. Well, 3 plus 2 is 5, and 5 is not divisible by 3, so 3 is not a factor of 32. Then I'm going to go to 4. Well, I know from my basic facts that 4 times 8 is 32. If I go to 5, it doesn't end in a 5 or 0, so 5 is not a factor. 6 would be only if 2 and 3 were factors, or it's divisible by both, and that's not the case. It's not divisible by 7, I know from my basic facts. 8 we already have because 4 times 8 is 32. 9, I would add them both together and find that it was 5 again, which is not divisible by 9. 10, it would have to end in a 0. And as you would keep going, you would find that once you hit pretty much the numbers 1 through 9, you would find out that at that point which number it was divisible by or comparable to. Now let's take a look at 100. I'm first going to start with 1 and 100. Nice and easy. Now I'm going to look at 2. Since it ends in a 0, I know it's divisible by 2. And when I think of this, I think of money. So I think of like 100 cents. So if I'm taking that and dividing it in half, that's going to give me 50. 3, if I added up all the digits, it would be just 1, because 1 plus 0 is just 1, which is not divisible by 3, so 3 is not a factor. 4. I know that 4 is a factor because I know that 25 times 4, just like 4 quarters, is going to give me 100. it ends in a 0. So I know that 10, or I'm sorry, I'm getting ahead of myself here. If I go to 5, it ends in a 0, or must end in a 0 or 5, which it does. So 5 times 20 is going to give me 100. And look at this, I'm going to run out of room here. So let's see, maybe I can rewrite it here, just a moment. Okay. I know 100 isn't divisible by 6 because it's not 2 and 3 aren't both factors. It's not by 7 or 8. 9 would be that I'd have to add up all the digits and get a multiple of 9, or a number divisible by 9. We added them up already and got 1, so that's not the case. But I do know that since 100 ends in a 0, it's divisible by 10. Now, 10 times 10 is 100, so we don't have to write 10 twice. We just have to write it once. Once we reach all of those numbers, 1 through 10 or 1 through 9, and have the matching number that multiplies together to get the number we're looking at, we know we're good. All right, example 2, this is kind of the next step. Here we're going to write the common factors for each set of numbers. So here we have 6 and 14. So first we want to list all the factors of 6 and 14. Well, from our previous example, we know that we have 1 and 6 and 2 and 3. These are not decimal points, they're commas, sorry. Okay, now for 14, we have 1 and 14. We know it's 2 times 7. It's not 3, 4, or 5, 6, 7, or 8. And these are all just from basic facts. So these must be the only 4 factors that we have. Now, we want to find all the factors that they have in common. So for example, all numbers are going to have 1 as a common factor. And here, they both have a 2. They both don't have a 3 or 6, so the only common factors are 1 and 2. Now we're going to do the same for 8 and 16. First, before finding the common factors, I have to write what the factors are. So I have 1 and 8, 2 and 4, and I know from my basic facts that these are the only ones. Now I do 16. I have 1 and 16, 2 and 8, and I know that 3 isn't 1, but I do know that 4 times 4 is 16, so I can just list 4 as the factor because I don't have to list it twice. I know it's not divisible by 5, 6, or 7, and once we're back at 8, 8 times 2 is 16. So now I look again for my common factors. Here I have 1, 2, 4, and 8 in common. So the common factors between 8 and 16 are 1, 2, 4, and 8. Now finally, we're going to find the greatest common factor for each set of numbers. So, just like we did before, first we need to find the factors of each set of numbers. For 4, we have 1 and 4, and then I know that 2 times 2 is 4, so 2 is one of our factors. For 12, we have 1, 12, 2, and 6, and we know that 3 times 4 is going to equal 12. Now I need to find the factors they have in common, which is a 1, a 2, and a 4. Now, the greatest common factor is exactly what it says. It's the greatest or largest factor they have in common. So for 4 and 12, the GCF, and this kind of helps us out a little bit so we don't have to write out the whole, each 3 words, is 4. It's the largest factor that they have in common. Sometimes they'll ask you to find the greatest common factor of up to 3 numbers or even more. So here we list the factors of each number. That's a weird 8. Now 3 is prime, so the only 2 factors are 1 and 3. That's going to narrow down our common factors for this one. For 12, we already did this, so we have 1, 2, 3, 4, 6, and 12. We did this one already above. That's where that came from. Now we have 18. So we have 1 and 18, 2 and 9, 3 and 6, and that should about cover it. So in common, we have a 1 and a 3. Those are the only ones they have in common. So we find the greatest one that they have in common, which is the 3, which makes the greatest common factor between 3, 12, and 18, 3. Now, pause the video and try these 2 problems on your own. Okay, here we go. I have, for the factors of 50, I have 1 and 50, 2 and 25. I know that if I add 5 plus 0, it's 5, so 3 is not going to be a factor. 50 is not divisible by 4, so 4 is not a factor, but I do know that 5 times 10 is going to give me 50. So the factors of 50 are 1, 2, 5, 10, 25, and 50. Now the second problem says to write the greatest common factor for each set of numbers. So first one is we have 16 and 24. So we have to start by writing the factors. Of 16 we have 1 and 16. We've already done this one. 2 and 8 and 3 and 6. 24 we have 1 and 24. I know 2 times 12. I know 3 times 8. And I know 4 times 6. Run out of room. So now I'm going to look for the ones they have in common. We got a 1, a 2, a 3, a 6, and an 8. The greatest one that they have in common is 8, so that's our greatest common factor. The next one, we have 5, 20, and 45. So we need to list the factors of each of these numbers first. So 5 is prime, so it's only 1 and 5. 20, we have 1 and 20. 2 times 10, and, 4 times 5. For 45, 1 and 45. It's not divisible by 2. 5 plus 4 is 9. So that means it must be divisible by 3. So 3 and 15. And then we also have, it's not divisible by 4, but it's divisible by 5, 5, and 9. Now we want to go through, circle the ones they have in common, which is just 1 and 5. The greatest one that they have is 5, so the GCF of 5, 20, and 45 is 5. Thanks for watching.